Indefinite integral. Indefinite integral. Learning outcome. From here, what we will get at the end of this video. So what you get. What you all will get. So we able to solve antiderivative. And then second, we are able to differentiate the properties of indefinite integral. So let me introduce here. Okay, now introduction. Indefinite integral, or sometimes called antiderivative of a function fx. So here the function of fx. So here and then here, and so then we get here, and then we have here, and so the integral, and so indefinite integral, we know that the fx plus c. So here we will see more after this. So a function, the derivative of the which is fx. So the function derivative, so fx, because the derivative of a constant 0. So here 0, the indefinite integral is not unique. So now the set of all antiderivative of a function fx is the indefinite integral of fx with respect to x, and denoted by integral fx dx. Generally know of antiderivative. So indefinite integral, also known as antiderivative. So a function f is an antiderivative of the f on an interval I. Then the most general antiderivative of an interval is fx plus c. So c is any real constant. So the process of finding the infinite integral is also called integration or integrating fx. And number 2, a function f is an antiderivative of x. So we know that when we know about the introduction before this. So fx, integrate fx dx equal to fx plus c. So from here we want to change into here, and then we have a plus c. Unlike the definite integral, the indefinite integral is a function. So we know that here is a function. Let some example here. So as example, sorry for my bad here. So d over dx, how we see that, over dx x 2. So we will get, when we derive this, we get 2x, right? And then when we have dx equals x2 plus 1. Also we'll get 2x, right? So we can conclude that indefinite integral is what what is 2x the derivative of. So we know that when we know that x2 or x2 plus 1 is equal that this formula x2 plus c, right? Okay, so because this is integral, so when we put this integral 2x dx, we will get x2 plus c. So in this topic, definite integral versus indefinite integral. Okay, when you see here, definite integral have the limits, that is 1 until 2. So we know that the definite integral have their limits. By the way, indefinite integral did not have any kind of limit here, so that's why we call antiderivative. So indefinite integral, so we cannot find that definite. Okay, next. So when we know before this definite integral, when we integrate x2, so here we can solve that like this. x2 plus 1 over 2 plus 1. So we get x3 over 3. So because they have a limit here, so we just change into this and into this, and then we get here. Okay, here. So for indefinite integral, we did not have any limit. So when we integrate x to dx, we get only x3 over 3 plus, don't remember put plus c, because here before this definition or introduction, we know that fx plus c, so don't forget about that. So every time when we do anything, we have a common mistake that we need encounter. Okay, so dropping the dx at the end of integral, we do that integral when dropping the dx at the end of integral, when we when here the integral fx dx is not equal to integral of fx, because here do not have this is a symbol of derivative. Okay, so next, to forgetting the plus c during the solution process. So we know that before this fx plus c, so when we forget here, when we integrate x to dx, it's not same at x3, even though this is a correct, but there's a mistake, a common mistake that student always do. Okay, so we need to see, so then this will be correct. We need some exercise to able to our learning outcome. to able solve the antiderivative and differentiate the properties of indefinite integral.
Solar, oh well, Omi, Crossies, Coco Chanel, palm trees, calm breeze, living in a dollhouse. I don't need a can, I can watch you walk out solo, but I got many I can thank. You could see it in my eyes, every time I blink.